Hi, I'm back to do another chapter review on Michio Kaku's Physics of the Future. Yeah, and so today I'm gonna be talking about chapter 4, nanotechnology. So once again, I'll be reading one section from the chapter. Alright, and the quote for today is, "The role of the infinitely small is infinitely large." Louis Pasteur said that. Mastery of tools is a crowning achievement that distinguishes humanity from animals. Accordingly, the quantum world is the first to call attention to the new realm of physics, was Nobel laureate Richard Feynman, who asked a deceptively simple question: how small can you make a machine? This is not an academic question. Computers are gradually becoming smaller, changing the face of energy. So it was becoming apparent that the answer to this question would have been enormous impact on society and economy. So that's the first section. And I'm going to read to you my research I did on nanotechnology. So, yeah. The internet is slow. Okay, so the definition of nanotechnology, or nanotech, is a manipulation of matter on an atomic or molecular and supramolecular scale. The earliest widespread description of nanotechnology is referred to the particular technological goal of precisely manipulating atoms and molecules for fabrication and macroscopic products, and is now referred to as molecular nanotechnology. So that is the definition of nanotechnology, and I personally think nanotechnology is cool because I just like small things in general. Like the video if you like small things. Because I think it's pretty cool how you can study. It's easy to study big stuff, alright, generally. It's a lot harder when you get down to the molecular scale. So, yeah. Let's say, I don't know how to explain why I like small things more. Would you rather be able to literally see atoms or see the biggest object on Earth? I think I personally would rather be able to see atoms. So I don't know how to explain why I like small things, but that's an example. And so, yeah. And nanotechnology can be used in many things. One thing, carbon nanotubes are part of nanotechnology, and carbon nanotubes are insanely strong. To be exact, 20 times as strong as steel, and they're a lot thinner. So yeah, that's cool. One problem about nanotechnology is that not nanotechnology, carbon nanotubes is that the longest nanotube is not very long. And let's go back to space elevator. If you want to make the elevator cord of carbon nanotubes, we'd have to find an efficient way to make the carbon nanotubes quickly, or else, first of all, we have to find an efficient way to make them long in the first place, and then we have to create them fast. So that's why nanotechnology is important. If you want a space elevator, you need nanotechnology. Because carbon nanotubes are part of nanotechnology. Nanotechnology, as defined by science, is naturally very broad, including fields of science as diverse as surface science, organic chemistry, molecular biology, semiconductor physics, microfabrication, molecular engineering, and etc. There's like 50 more. I'm not going to say all 50 of them. Scientists are currently debating the future of implications of nanotechnology. There's not many things we use nanotechnology for currently, but scientists mainly say they will have a huge impact on medicines. I explained in the last video why. Yeah. But thing is, nanotechnology raises many of the same issues as new technology, including concerns of toxicity and environmental impact of non-nanomaterials, potential effect of global economics, as well as speculation of various doomsday scenarios. The origins of nanotechnology. They were inspired by Feynman. That's all my research says. I was in a rush. Sorry, I don't have a lot of research about the origin, so I was kind of in a rush because I'm busy. Yeah. I mean, that's all that this chapter for nanotechnology in this book is actually pretty short. It's only like 10 pages long compared to other pages that are like 50 pages long. Okay. What else do I have in here? Nanomaterials. Different. I'm gonna say a list of nanomaterials. Silicon solar cells. Carbon nanotubes. Tetrahedron nanomedicine. Nanopillars. Quantum dot pillars. Yeah. Biomedical nanohelixes. These are all used for medicines except for the carbon nanotubes. I mean, we're not really using nanotechnology too much currently, but we will be seeing them a lot in the future. So yeah, the only thing that's not medicine here is carbon nanotubes. Everything else is probably, they say they're going to use it for medicines and surgery and all that good stuff. Applications. On August 21st, 2008, a project on emerging nanotechnologies was created. The project list of all the products publicly accessible online database. So yeah. Database. Some food products, carbon allotropes used to produce gecko tape. Gecko tape is used on gecko gloves, and people use gecko gloves to climb stuff like walls. This is just a list of this company used like a bit of nanotechnology science to create these things. They use silver in food packaging and clothing, disinfectants and household applications. Use zinc oxide. They all use nanotechnology, like the science of nanotechnology, to help them create this stuff. And cerium oxide is a fuel catalyst. Now, this fuel catalyst is important because when we're going to space and stuff, the more fuel you have, the heavier it is. The heavier it is, the more fuel you need. But the longer the distance, the more fuel you need, which adds weight, which makes you need more fuel. So it takes a lot of math to figure it out. When you use cerium oxide as a fuel catalyst, it'll get the fuel starting a lot quicker. It would be a bit more efficient, but it'll still help. A little goes a long way when it comes to science, especially when it comes to rocket science and stuff. So that's it. That's what I have for nanotechnology today. Thanks, and stay tuned.